Hello everyone, welcome to lecture 2.1 of testing of hypothesis large sample. In this lecture, we are going to do one problem under the topic test for the significant difference between two means. Procedure. Step 1, write the given data. Step 2, write H0, H1. Step 3, find the test statistic Z. So in this topic, we have three cases for formula. Z is equal to x1 bar minus x2 bar by root of sigma 1 square by n1 plus sigma 2 square by n2. So if we know two population variances are standard deviation, then we'll use this formula. Instead of sigma 1 and sigma 2, if we know S1, S2, that is two sample standard deviations or variance we know, then we will use this formula case 2. Then if we have only one population variance or standard deviation sigma, then we will use this formula case 3. Then step 4, write the table value, and the last step, write the inference. Two types of new cars produced in our country are tested for petrol mileage. One group consisting of 36 cars averaged 14 km per litre, while the other group consisting of 72 cars averaged 12.5 km per litre. The population variances are 1.5 and 2.0. Test whether there exists a significant difference in petrol consumption of these two type cars. So here it is given sample 1 size is 36, sample 2 size is 72, and the mean of sample 1 is 14 and the mean of sample 2 is 12.5 km per litre. And the population variances, sigma 1 square is 1.5 and sigma 2 square is 2.0. So here we are going to test the difference between two averages, that is means. So it is coming under the topic large sample test for the significant difference between two means, because the n values are greater than 30, it is coming under large sample. So this problem under the topic test for the significant difference between two means. So now we will write the given data. First n1, which is 36, then n2, which is 72, x1 bar, mean of the first sample 14 and mean of the second sample 12.5 km per litre. Then sigma 1 square is 1.5, then sigma 2 square is 2. So now second step, H0, the null hypothesis H0, it should be always something is equal to something. Here we are going to test the difference between mean. The population parameter for mean is mu. So difference between two samples. So mu1 is equal to mu2 is our H0. And H1 is always not equal to or less than or greater than. So here we have mu1 is not equal to mu2. That is, if H0 is true, then we conclude that two samples have the same mean. There is no significant difference between two means, sample means, right? So if there is a significant difference here for H1. Next we will write the test statistic formula first, then we'll find the value. So here we know the values of sigma 1 square and sigma 2 square. So the formula is x1 bar minus x2 bar by root of sigma 1 square by n1 plus sigma 2 square by n2. So this is equal to x1 bar 14 minus x2 bar 12.5 by root of sigma 1 square is 1.5 by n1 is 36 plus sigma 2 square is 2 by n2 is 72. Now we'll find the value 14 minus 12.5, close the bracket, divided by square root of, put the bracket, 1.5 for the first term, open another bracket, 1.5 divided by 36, close the bracket for the first term, plus second term. For second term, open another bracket, 2 divided by 72. This bracket is for second term, and the full term another bracket. So now we are getting 9 root 10 by 5. So that in decimal we are getting 5.69. So the value of Z is, the calculated value is 5.69. The next step, we are going to write the table value. Here it is not given the level of significance. So we'll take 5% level of significant. So the table value of Z at 5% level is 1.96 and the calculated value is 5.69. So for two-tailed test, here not equal to means two-tailed test. So for that we have mod Z. We want mod Z, which is 5.69. Mod Z is equal to 5.69, the calculated value, which is greater than 1.96, which is our table value at 5% level. So if we have greater than, then H naught is rejected. So what is the inference? If H naught is rejected, there is a significant difference between means. H naught is rejected, then H1 is accepted. Therefore, the difference of mean is highly significant. Mean is highly significant. That is the inference. Thank you.